Alright, this video is going to discuss alarms, faults, and errors, and a little bit about mastering for FANUC robots. Alright, so one of the errors or faults that we might see is the external e-stop. Okay, there's several different e-stops that can be wired into the board. So obviously you have to when you wire up an e-stop, there's actually two separate circuits, and so they both have to be wired in, and they have to have the proper voltages, or you'll be receiving an external e-stop error, or same with the fence error. Any kind of external sensors or trips to protect the users. Obviously, if you're getting an error, you have to, of course, first correct that error before you can reset the error. But once you correct the issue, then you can press the reset on the teach pendant, and the robot will clear that fault. Alright, so when we get errors or faults on the robot, of course, it could be some kind of physical hardware issue. And again, before you can clear that fault, you have to, of course, correct what the actual issue is. It could also be some kind of software setting, and we'll discuss a couple of those, or it could be the e-stop, which we just mentioned. Most of the common faults that you're going to see, you can either simply press the reset key, or some of them will require the shift reset to allow you to move beyond that point. Like the DCS errors, for instance, reset doesn't do anything, but shift reset will let you jog the robot out of the area where it's at that's causing the fault. And then once you get it clear of that area, then you can restart the robot. So when these faults and anytime a fault occurs, it generates an alarm. There's alarms are generated from various different items in there, and so we need to view these alarms once in a while. Especially sometimes when you get an error, you may actually get 2 or 3 errors, and the one that's really causing you the most problem maybe got covered up by a less important error that is recurring. We have one robot in the lab which generates an I/O error a lot that really doesn't hurt anything that we're doing, but it hides the error that you are getting. So what you need to do is you need to come to the alarm screen. So you have to press the menu key and then come down to number 4, alarm, and look at the alarm log. So when you look at the alarm log, then you can see what alarms have occurred. All right, I just mentioned the DCS. If you have a DCS, remember, talked about this the first week. DCS stands for dual check safety. So if you have that installed on your robot and you have it set up, what that means is if you go into, if the arm starts entering an area that's been set up as a no zone, then the robot will shut down, and you'll have to jog the robot back out of that area. So you have to press shift reset. Of course, you have to go back to T1 mode and turn on the teach pendant to jog, and press shift reset to temporarily at least clear the dual check safety error, and then jog the robot back into the safe area. Now, if you accidentally hit the wrong jog key and jog further into that area, it's going to immediately shut down. So it's only going to travel just a small distance and shut down and generate the DCS error again. So again, you'll have to press shift reset and then jog it the correct way to get it out of that area. All right, now this is one error that you're going to run into a lot in the classroom here, and that is you get an error, run request failed, uh, robot locked or task locked, because some task is already running. So you get this a lot because when it's your turn to come up to the robot, somebody else was already up there running their program. So when you want to run your program, you're going to see this error pop up about task locked by another user, is one of the messages that it shows. And when you see that, the problem is that it's still trying to run somebody else's. It may be in pause or hold mode, because the robot's not actually moving, so it's, technically it's not running the project, but it's sitting there waiting to run that program. So you first have to clear out that program so you can get it to run your program. So the way we do that, we select the function key, FCTN, and then the very first option there on the main screen is option 1, abort all, and that will terminate any of these tasks that it's currently set up to run, so that you can actually select your program and run your program. So remember this, like I say, you will most likely you will run into this many times throughout the semester as you come up to your turn on the robot and try to run your program. Another big error that we run into is the singularity. The singularity occurs when the robot is basically what happens is when the wrist of the robot is straight. So if we kind of see if we can kind of look at my arm here. So if the arm is straight here, then what that's saying is that if you wanted to kind of move to like another, like flip it upside down, you could either turn clockwise or you could turn counterclockwise. And so it could kind of go both ways. And so it doesn't really like that. It likes to go just one way. I'm not sure you were seeing the camera there. All right, so here's the, if you think about the robot arm, and this is the wrist of the robot, so you've got J6 out here and J5 and J4 at the elbow. And so if you wanted to go and turn over, you could turn over either way. And so you could go in two directions, and the robot can't decide which direction to go because it's got two choices. And since it's got two choices, then it's a little confused. It wants one choice. Well, that's the term singularity, right? It wants one singular choice in which it should make the move. And so if it could go either way and it can't kind of make up its mind, it gives you this singularity error, saying, I'm not sure which way to go. So what we have to do then is simply jog J5. So if you jog J5 down or up, so that now it's got, it's like, well, wait a minute, it's definitely going to be better to go clockwise or counterclockwise or whatever way it decides. So when you do that, you need to you just need to jog J5. The recommendation is jog it about 10 degrees. So like I was demonstrating like a full 90-degree turn, or 90-degree. You don't have to go 90 degrees. They recommend 10 degrees. Sometimes you can get away with less than that if that's a problem, but you definitely gotta jog that J5 and give it a bit of an angle, and that'll allow it to do that. Now, if you're jogging in the joint mode, this should never be a problem. The problem occurs because when you're jogging in the joint, you're just jogging one joint at a time, so it's not really an issue. So to get out of this, you got to go to joint mode so that you can jog just J5 and nothing else. All right, so when we start talking about robot controllers, Robot controllers can handle, it depends on which controller. So the R30IA controller, for instance, can handle a total of 40 axes. Okay, so we know the default standard robot's got 6 axes, but we can connect up another 36 axes to this one robot, and it can control all 36 of them simultaneously. But to do that, we group the axes. So we can put 9 axes in a single group, and we can have a maximum of 8 groups. All right, so 8 groups with a maximum of 9 axes in each one. And of course, the joints 1 through 6, the first 6 axes, which are the robot itself, are always going to be part of group 1. All right, but we can create 8 more motion groups with 9 axes each. Now I know that's 72, but the R30IA can't handle 72 axes, but the R30IB model actually can handle up to 72 axes. All right, so when we a lot of times we'll get a fault like an axis limit error. So you'll get a limit error fault which is the motion-17 error, which is the limit error. Now when you get that, it gives you several bits of information here. It gives you the group. It tells you a number, and then it gives you a number. It tells you which axis is upset. All right, but this axis is a hexadecimal value. So we need to kind of review binary and hexadecimal. Now remember, there's 9 axes in the first group, and there's up to 9 axes. A lot of times, we just have the standard 6 axes, but we could have those extra 3, so we could have a total of 9 axes in group 1, and we could also have a group 2 and a group 3, and they could have axes. Now think about this. You've got 9 axes, and when one of them hits a limit, it's upset, right? It's like, okay, I'm no longer happy. I've hit my limit, and I don't want to go any further. So it outputs that axis limit, that motion 17 on the next slide there, and it says we're not happy. But to understand which axis isn't happy, we have to understand a little bit of binary. So when you look at this, these are just flags. If this is a 0, then that axis is happy. If it's a 1, that's a flag saying that axis 1, this one right here is axis 1. It says axis 1 is not happy. This 0 says axis 2 is happy. This 0 says axis 3 is happy. This 1 says that axis 4. So it starts counting from the right. So we have 1, axis 1, axis 2, axis 3, axis 4. All right, and that's a set of 4. And so then this will be axis 5, axis 6, axis 7, axis 8, and then the 9th one is kind of out here by itself. All right, but so when we look at these are just flags for each individual axis. But let's say that 2 axes get upset at the same time, like we've shown here. So this is axis 4, and then 3 and 2 are happy, but axis 1 and axis 4 are unhappy. So if we come over here now and look at this binary chart, and we see 1, 0, 0, 1, that's the number 9. So down here is the number 9. The number 9, 1, 0, 0, 1, that says, hey, I'm unhappy. And so what it's saying, though, is it's saying that axis 4 is unhappy and axis 1 is unhappy. So when we look at like this motion error here on the next slide, if we saw the number, well, let's see what I've got here. I've got a 1, 0, 0, 1, 0. So notice 0, 0, 1, 0, that's up here at 2. That's up here at the 2. 0, 0, 1, 0 is 2 in hex. So we have a 1, a 2, and a 9. So if we come over here to the motion error, if it said, it would say something like group 1, and then if we had a 1, 2, 9, so 1, 2, 9 is saying that axis number 9 is upset, axis number 6 is upset, axis number 4 is upset, and axis number 1 is upset. So this is actually saying we've got 4 axes that have hit their limit, all essentially at the same time. That really doesn't happen too often. Usually it's only 1 or 2 axes that are nearing that limit at the same time. All right, so this is kind of an academic example, but you probably don't see it too much. But 129 hex. So this is what it would show up there. You would see this motion-017 limit error, and then in parentheses you'd see like G:1 for group 1, and then A being the axes, 129 hex. So it's telling you that this number 129 is a hexadecimal number. Okay. And so again, if we flip back and we look at this, okay, here's the 1, here's the 1, here's the 2, and here's the 9. 1001 is the 9. So it's saying, well, I'm not happy. Axis 9 is upset. It's beyond its limit. Axis 6, this one here is axis 6, and it's unhappy. Axis 4 is unhappy, and axis 1 is unhappy. So we would have that motion error would be a 129. So this would be 100A, this is group 1, axis 129 hex. Okay, so that's what that would be telling us. We would see that motion error. We would see that motion-017 error, which is a limit error, and then it would be G1A129 hex. And so again, that's telling us that let me just change this here. So this is saying that axes 9, 6, 4, and 1 are all upset. Okay, all right, so they have hit their limit. They have hit their limit, and they've set a flag. So these are flags. A 1 means the flag is set, 0 means the flag's not set. All right, so so if we're at these limits, we got to kind of ask, why are we hitting this axis limit? And so chances are we got, the axis limits are preset. We might be able to change them if they had been arbitrarily reduced from the maximum range that these axes can travel, and we might be able to extend it a little bit and get beyond that error. Okay, and then we could just hit reset. But if we change the axis limits, we kind of talked about that in a different lecture. Yeah, we'll have to actually reboot the controller once you make that change. But if you can't change that, then you're going to have to figure something else out, like maybe sometimes rotating a different axis or shifting a different axis will allow you to reach in a different way to get beyond that limit. Or you're going to have to maybe move where you're picking something up or setting it down or something along those lines, and you're going to have to shift something a little bit so it can reach it. All right. Chain errors. We kind of already talked about the emergency stops and those kind of things. Those are kind of what they're referring to here, as long as at the chain error. But sometimes it pops up at the, if it says emergency stop is tripped, are open, I mean, that's pretty obvious, figure, somebody tripped the emergency stop. Of course, you need to make sure that, everybody is safe and clear, and everything's all right. And then you can reset the emergency stop, reset the error on the teach pendant, the fault on the teach pendant, and move on. But but sometimes it's kind of a voltage. So you remember on the other slide we were saying that there's actually like two sets of wiring, and so sometimes for whatever reason there's some sort of voltage interruption on these connections. And so when that happens, it'll sometimes spit out a chain error. And so you have to clear the chain error. And this is one of those errors that is not necessarily obvious. What we have to do is go into the menu, alarm, go to the alarm log, and then in the alarm log, you'll see down there at F5, you'll see, or it might be F4, I didn't label it here, but reset _1 chain. All right, and that'll reset the single channel fault error. And so when you press that, it's going to pop up there, and you have to press F4 for yes to reset, or F5 is over here saying no, don't reset. But I don't know why you wouldn't want to reset it. But you have to, again, you have to, if you're getting that chain error, you need to come to the alarm menu, go to the alarm log, and then one of the soft keys up here, I believe it's F4, is labeled this reset one chain, single chain. That one's kind of for the single chain, so we're going to reset that chain fault, and then it'll pop up and say, are you really sure? And of course, yes, we are sure. We want to reset that. That happens, that occurs once in a while in the class, and I'm not sure exactly what causes it, but usually coming in and just resetting that will clear that fault, and then you can move on. Okay. But again, a lot of times that happens on the one robot that spits out the IO error, and so sometimes you don't even see the chain error appear because it's covered up by the IO error. So you're going to see the errors. The errors are going to show up right here in this like blank spot, right up in here. If you can see that mouse moving, that's where those error messages are going to appear. But if a couple of them occur within the same general time span, only the latest one's going to show up there. And so again, you have to hit press menu, come to alarm, and view all of those errors to see what they are and correct them as needed. All right, so just some general information here. If you go to menu, next, and status, and then under status is the version ID. This is important if you're planning on, like, if you need to purchase some extra software for your robot. They always ask you for some of this information here. So they want to know your version of the handling tool. They want to know your robot, the version of your robot, your controller ID number. This controller ID number, known as the F number, it's F01234 here. This is what it shows on this screen here. But that is the F number of your robot. It's a serial number of your robot. And so if you look on the robot, you'll see the F number on the robot. If you look on the controller, you'll see the F number on the controller. In general, these should match. Okay, when you buy the robot, you get the set. You get the robot arm and the controller together, and they have the same controller ID or F number here. If they don't match, if you try to plug in if you have like two robots and you try to plug in the arm of the second robot into the controller of the first, you're going to run into issues. It's not going to work. Okay. All right, so mastering. Mastering is when all the joints are set to their center position. Okay, and then you record the encoder values, as we talked on in the lecture on variables. You record your serial pulse coder values, and so you set your angles are set to 0. You're in the center position, and then whatever the encoder number is on the actual encoder, which we can't see, that's buried within the encoder. But if we go into under variables, we can see what those numbers are, but they don't mean all that much to us just looking at those numbers. But we have to store those. So again, if your batteries die, you forgot to replace them, and your battery dies, then, or if you have to do some repair, you have to put a new servo or belt on the robot, you're going to have to do a remastering. Okay. All right, so remember, to replace your batteries, make sure power is applied, because if you shut off the robot and then you yank the batteries, it's going to forget these serial pulse encoder values, and you get to remaster your robot. All right, so to master the robot, what we need to do is move the axis to its center and line up the marks. All right, so you have to line up these marks. So you see these marks down here. You need to mark these so that the center lines are lined up. So these are what they refer to sometimes as the witness marks. And you need to line up, so as you jog the robot, there's going to be a matching mark on the stationary portion of that joint. So this is one robot joint, and so one part of this is going to move as you jog the robot, and the other part is stationary, and you need to line these up. So will you line these up, and that's your 0 joint mark. And then you do the mastering, which stores whatever the encoder value number is with these lined up. Now, in the classroom, we have the LR mate robots. The LR mate robots actually don't have these witness marks like this. They just have little scratch marks or on them. So they're a little harder to see. There, but they have these little scratch marks, and you simply gotta line up to the 2 scratch marks, and that is where you would set the master then. So you line up all your axes to do that. So if we look here, basically you see the robot here is kind of standing straight out, and the arm is pointing straight out. So you have J6 is right here, and it needs to be centered. J5 is centered so that it's straight out. J4 needs to be centered. J3 needs to be kind of straight out. There will be these witness marks on there, J2 and J1. So each one of these axes are going to have that mark on them. Now, when you're trying to teach, or when you're trying to master the robot, you may want to say, well, I'm going to take axis 1, and I'm going to line up axis 1 to be at its witness mark. Then I'm going to take axis 2, and I'm going to line it up to be at its witness mark. And then I'm going to line up 3. The problem is, if this is a large robot that's, by the time you get J3 lined up to its 0 mark, it's standing out here, and this arm might be 6 to 8 feet up in the air. And you may not even be able to see the witness marks of axes J4, 5, and 6. So what I've learned to do is you actually kind of work backwards. You zero out J6, J5, and J4 so that you can see them. So you jog the robot so it's down here where you can easily see J4, 5, and 6 and line them up, get them lined up to their witness marks. And then don't touch them. And then when you line up J3 and J2, the arm's going to be sticking way out here. And like I say, it's easily, on some of these robots, it could be 8 feet tall or higher with you standing on the floor. But you don't want to have to get on a ladder to try to climb up here and see J4, 5, and 6 and their witness marks. So what you need to do is you actually get J4, 5, and 6 set to their 0 to get their witness marks set, and then do J3 and J2. Okay, and J1. So you need to work backwards when you're doing the mastering. Otherwise, you can't see those 4, 5, and 6 axes, because, like I say, they're 8, 10 feet up in the air, and you'd have to get a ladder to see them, which is just, a little dangerous when you're trying to jog a robot and you're standing on a ladder, and there's no need to do it. So just bring J3 and J2 down as needed so that you can easily see J4, 5, and 6, set those marks, and then set the marks for J3, J2, and J1. And then you would go to the mastering screen and say, okay, I've got them all lined up. And you would say master, and it'll take and it'll remember that position. It'll remember those encoder values. So that's how we would master the robot.